the next function is inverse secant. F of x equals secant inverse x, and the question is find the derivative of secant. And this can be also written as y equals inverse secant, and then find the derivative of the y. Now, first thing is the domain of this function, like what are the possible x values? For that, I want to express it as a secant, so y equals inverse secant of x, that means x equals secant of y, and secant is the same as 1 over cosine of y. And if x equals 1 over cosine, cosine is always between negative 1 and 1, so 1 over that should be either smaller than negative 1, smaller or equal to negative 1, or greater or equal than 1. So x could be less or equal to negative 1, or x could be greater or equal to 1. And this is the domain of this function. So x is less or equal to negative 1, or x is greater or equal to 1. Now how to find the derivative? To find the derivative, we will treat the given function inverse secant inverse of x, as a function implicitly given by the equation x equals secant of y. So we treat f of x, or y equals inverse secant inverse of x, as a function implicitly given by the equation x equals secant y. And we will find the derivative using a regular method applied to implicitly given functions. And this method is left hand side derivative equals right hand side derivative. Now for this equation, left hand side derivative is just x, therefore the left hand side is just x, therefore the left hand side derivative is derivative of x, which is just 1. So left hand side of the equation is just x, so left hand side derivative is just 1. And the right hand side of this equation is secant y. And so to find the right hand side derivative, since it involves y, to find the derivative we need to calculate derivative normal way, like derivative of secant, and then multiply it times y prime. Now derivative of secant is secant times tangent, so it will be secant of y times tangent of y. But then we need to multiply times the derivative of y times y prime. That's the derivative of the right hand side. Now we equate derivative of the left hand side equals 1, and derivative of right hand side is all this expression, so we need to equate them one to the other. So we get one equals all the secant of y times tangent of y times y prime. And now it's easy to isolate y prime, we just need to divide y 1 over this. So y prime equals 1 over secant of y times tangent of y. And now this is a good formula for implicitly given function, to find derivative of an implicitly given function. However, in this context, we want our derivative to be expressed as a formula with x, and not a formula with y. So we need to express it as a formula with x. Now, how can we express it with the formula with x? Well, x equals secant y, so this portion is already x. But we do need to express tangent of y as a formula with x. And for that, we need to express tangent of y as a formula with secant of y. Need to express tangent of y as a formula with secant of y. And how to do this? For this, we will use the main trigonometric identity, which is sine square of anything, I want y, plus cosine squared of the same equals 1. Now I need to express tangent as a formula with secant, and secant is 1 over cosine. For that I need to divide all of this equation over cosine, in this case cosine squared of y. So over cosine squared of y, and here over cosine squared of y. Now sine over cosine is tangent, and sine squared over cosine squared is tangent squared. So tangent squared of y plus. Now cosine squared over cosine squared is just 1, so plus 1 equals. And here we have 1 over cosine squared. Well, 1 over cosine is secant, and 1 over cosine squared is secant squared of y. And now we solved it for tangent squared, then we need to subtract y, so we get tangent squared of y equals 1 minus, equals secant squared of y minus 1. And that's precisely what we need. We have expressed tangent as a formula with secant. So since tangent squared equals secant squared, and we need just tangent without square, so we do square root. So tangent of y equals square root of secant squared of y minus 1. And in order for inverse secant to work, so it's same as inverse sine, so we need to assume that y is between 0 and pi, and for such values, tangent should be always positive. So secant is 1 over cosine. Let's see, secant is 1 over cosine. So just to make it simple, we assume that tangent is always positive, so this is a positive. So assume tangent y is always positive. And now this is positive, so we have y prime, which is the derivative, equals 1 over secant of y times tangent of y. And secant is just x, so it will be 1 over x times. And for tangent of y, we have this formula, square root of secant squared of y minus 1. But secant y is equal to x. If secant of y equals x, because y equals secant inverse of x, inverse secant, so we get square root of x squared minus 1. So it will be x squared minus 1. This tangent y becomes square root of x squared minus 1. So here's what we got. If we start this function f of x equals inverse secant of x, then the derivative is 1 over, and the denominator is x times square root of x squared minus 1. This is the answer for the derivative of inverse secant.